This is Darrell Lee Berry Jr. back for some more Science Hour. Hopefully, from this, I actually picked up a new tutoring student. I also focused on preparing my lesson for the Sunday session that I totally lost track of time. So rather than making up that time, since I had a thermodynamics exam coming up as well, I just said, well, I'll just go a bit longer on Saturday because I have to read this Mickelson Morley paper anyway. So I'll be writing a paper on it for my relativity class. So I guess I just got a Saturday off, I guess. Oh, and I says my mic is choppy. Let's see what I can do about that. A moment here. Does this help? Maybe turning the gain down. Does this help some? Or maybe moving it back a little bit. Popping. Okay, give me a moment here. Does this help? Testing, testing. How does this sound? New, different effect on. Is this better? Testing, testing. Okay, glad that's a little better. And I'll make a few more adjustments as well. See if this helps. Awesome. So let me know if it changes any more, if it needs any more adjustments. So thanks for letting me know, by the way, Eyes of Charlotte and Bella. I appreciate it. Where does that name come from, by the way? Eyes of Charlotte and Bella. Is that, of course, whenever I think of Bella, I think of Twilight, which was one of my favorite movie series. I never read the books yet. I just haven't took the time to read them. Thinking about it, that is a series I need to read. I never took the time to read the series yet. Ah, your daughter's awesome. So your daughter is actually named Bella, or is it like Elizabeth or and Bella for short? So somebody who's a awesome. I believe that is the name of the Bella in the movie as well, if I remember right. Isabella. I remember one of the vampires calling her Isabella before, but I could be wrong about that. It's been a while since I saw the movies. I need to see them again. Uh, it's one of those movies I have to watch regularly, not as often as Harry Potter. I need to watch that series at least once a year. I don't think I've ever missed a year, even since I've been in school. But I think it's been a few years since I saw Twilight. I think I got to see that again. And you were saying, to go in reverse of the comments, you were saying get out of flat Earth. Were you saying that I should get out of flat Earth, or just a general statement of people generally should stop talking about it? And she said, and I says, never saw a Harry Potter film. Oh, you should stop causing yourself that suffering and watch some Harry Potter. They're awesome. I've already have. When is the last time you saw me talk about flat Earth? If you can recall. And sometimes people in the chat will bring it up. That is true. But like, when is the last time you remember me? Other than when somebody brings it up, like you're bringing it up right now. Sometimes other people's in the streams. Yeah. So the after the final experiment, uh, even before that, really, I was starting to get tired of talking to these people Uh, because you see the debates I did, you point out that they're wrong, they just change the subject or run away or lie or whatever over and over. So I was already starting to get tired of talking to them. Then after the final experiment, it was so interesting being able to see the lights come on in Whitsitt's eyes and Journalism's eyes as they're being called shields and they're being called liars for just telling the truth of what they saw in the article. Like how, NASA, they're saying like how they're not lying, and they make it sound like that's so reasonable. But now the same thing was being applied to journalism and Witsit, and it was like I was there, and you could, and of course, journalism got out of it. What's going on, the mathematician? Good to see you. Oh, I'd be willing to hear about that. But then after I talked about the fault on both sides, but then after I talked to Flatzoid, I challenged him in our debate that he was just repeating something that he heard on a meme or something that he didn't really understand the laws of thermodynamics. He accused me of being condescending. I brought him on to have an honest discussion, and all he can do is lie and run and try to make it a gotcha. So that's probably, and so I just get more and more fed up talking to those people, and that's why my show is now the Science Hour is not realizing the shape. Realizing the shape was more based upon trying to debate or talk to the flat earthers. But Science Hour is just about science. And of course, like you said, I did several debates and I made several videos about it, so people still come on and bring it up from time to time. So I mean, I'll talk about it if somebody brings it up. But I've already told Modern Day Debate that I'm not interested in talking to these people anymore. So I won't be going on there to debate flat earthers anymore. Um, if somebody comes on trying to talk about they know better, I'll give them an opportunity to put what they want to say in writing, and I'll look it over. Other than that, I don't really talk about that anymore. When you were saying there's fought on both sides, by the way, you're welcome to hop on. By the way, there's a Discord link. That Discord link in the video right there. I'm on Discord right now. So and where's my window? There we go. Oh, looks like I let it close. Hold up here. Boom. Screen is sharing again. But this Discord, the screen share here that is on Discord. So if you want to hop on and chat some, Bella, or Charlotte and Bella, or I guess I should call you Ice, and Charlotte and Bella are your daughters. If you want to hop on and talk on Discord, Ice, you could just input that link right there that's in the video, and you'll be able to hop on. Sure, I'll see what you have at the end of the stream, the mathematician. I'll talk with Charlotte a bit about this topic, and then I'll talk about some Mikkels and Morley, and then I'll take a look and see what question you have at the end. And keep in mind, I do offer tutoring. As I was mentioning earlier, I have a regular student right now that I meet for tutoring. I do have room for another one, so it might be best for you to get some tutoring sessions, and we could just spend like an hour and go in detail and look at the concepts and solve problems and whatever you need. But I'll take a look and give it a few minutes at the end of the stream as well. And you were saying as of uh not right now, but I'll look into it at the end of the stream after we get the scheduled stuff going. But like I said, I'm willing to do help on demand. That'll be a tutoring session. Just sign up for tutoring. If you want, you have my email. Email me. We could set up a time for tutoring, and we can meet regularly once a week or more, and we can go over problems or concepts or whatever you like. And when you were saying, is that there's fault on both sides, what do you mean by that? I'm very interested to hear. Yes, right now it's 30 an hour for college students. Uh, uh, but I could go down to 25, 20 for high school students. I mean, usually like 25 for high school students, 30 for college students for an hour. So let me give you the link to my, I'll post the link in the chat where you can read about it, one of the links. So actually I have a STEM site where I'll start adding more stuff there, but I already have my tutoring stuff there. So you can go there and read about the tutoring, read about some of my background, read about how much it costs. And if you need some help, I can be flexible on, a little flexible on the cost of it. And I'm quite interested, by the way, eyes, when you were saying both sides and shoot. And oh, what's going on, Bandsaw? And I'll see what I says about both sides because I'm always interested to hear how I might be able to improve. I mean, we already know what's horrible about the flat earth side. I mentioned a few of them earlier. What some things I might have been able to improve on, eyes, when you were saying how it's on both sides. And Bandsaw, what's going on, Bandsaw? Bandsaw was saying from watching a few debates in the past, I think there are people on both sides that don't debate in good faith. I was referring to you. Uh, I mean, think about that. Who can you think of, Bandsaw? Who are you aware of that doesn't debate in good faith on the globe side? Mhm. Awesome. Well, thanks for getting it for Bandsaw. What's going on, Lisa? Good to see you. I was saying last week, excuse me for missing last week, I got a new tutoring student, and I was so focused on preparing my lesson, we just got everything arranged like a day or two before. So I was so focused on, I take my tutoring seriously, so I put a lot of time into the preparation. And I was so focused on preparing, I lost track of time. But now we have a regular thing going, so on Sundays, so I have enough time to prepare throughout the week, so I should be fine going forward. Hey, what's going on, Catherine? Thanks for saying, Catherine. I appreciate it. Yeah, I thought, man, I don't know what's going on. I guess she hates me now or something. I don't know, but perhaps we could just see it as a misunderstanding. Um, I can say MC Tune. There's one thing I saw him do on the stream where apparently this guy accused him of being a pedophile or something, and apparently somebody else said that guy was a pedophile or something, and then he like said he was going to debate the guy and got him on stream to debate, but then like called the police to report it while he was on and then said he's not going to debate him. That's like the only thing I could think of where I think MC Toon was acting not in good faith. Because I think if it's really something that you're supposed to report, then you should just report it. Like he was saying, they should just report it. Or just, I don't know. I think I would just tell him up front, I'm not going to debate you, and this is why. I don't know. That's the only thing I could think of where I think MC Toon was not in good faith. Otherwise, it seems to me that he's just, that's the people he's dealing with. And that's one reason why I want to stop talking with them. They're just so dishonest and manipulative and deceptive and running in general. Like Bandsaw, I know we can have a good conversation, but look at the conversation I had with Flatjoy, I guess a few months ago. But he deliberately, according to him, I played him saying it. According to him, he deliberately gave me a link and lied about the link, lied about where he got the equation from to throw me off and confuse me about what he was saying. That's clearly dishonest and not in good faith. So the only way I could continue to have conversations with that guy is to put a large portion of my attention into capturing his lies. He put a link out saying, I got an equation from this link. I got to ask, did you really get it from that link? We got to look at the link to see if it's really there. I can't just take anything he says at face value. It has to be. So I think MC Toon, for the most part, recognizes that, and he's willing to do that. He's willing to meet them where they're at, and I'm not. I want to speak with honest people. I want to speak with people I can just have open conversations with, and you know, cool conversations with. I don't want to have to sit there catching people in their lies and you know they avoiding questions and running instead of just saying it. I just don't want to deal with that. So I think MC Toon is just responding to what they're saying. Um, yeah, exactly. Gotcha's manipulation, and you can see it in the Flatzoid debate talk. You know, even when he gave the equation, he was saying it was the entropy equation. In my mind, I'm thinking the actual empathy equation. I'm thinking he's just writing it a different way, but that wasn't the entropy equation. It was the wrong equation from the start. But everything they say, I have to question it, and I just don't want to talk with people that have to do that anymore. So that's why I rebranded my channel, made it Science Hour. So I just stopped engaging with those people. I let in modern day debate know I'm not going to be debating against these people anymore. I don't want to deal with them anymore. And now I speak with people like my tutoring student who wants to learn science. We have honest, open discussions, and we don't have to. I don't have to deal with that. So but I mean, I do believe that, at least from my experience, it seems like the people are responding to what the flat earthers are doing. But again, I'm seeing it from my perspective. So from your perspective, Ben, so as a flat earther, perhaps you could see, maybe you see other globers that I'm not aware of, or maybe you see things that whoever did, MC Toon, whoever did that I didn't see because maybe I don't look, at everything that they do from that perspective a lot or see as much of it. So could be the case, but again, that's why I pull myself out of it. So, and Catherine says, I hate the way they're dividing all Hebrews into two groups according to belief, claiming the superiority and the abusive ways. Science wasn't like that at university. Science is not like that at university. I'm a learning assistant right now. I'm a private tutor right now. Uh, um, I mean, this semester, I'm earning a bachelor's degree, a bachelor's of science in astronomy and physics. I'm going to be starting grad school in the fall, and again, I'll do a reveal stream sometime soon, probably in the summer, about where I'll be going in the fall for grad school. So yeah, science is not like that. It's just one thing I started to realize, you all, when I was so focused on the flat Earth discussion, your perspective starts to shrink to fit that discussion, but you have to realize that the flat earth discussion is a very small pea-sized discussion, right? So they're having this discussion about flat earth, right? And saying all of science is wrong, but only because science is right, we can communicate right now. You see me through a camera, the lens of which is based upon laws of optics. The electricity is coming from a power plant based upon the laws of thermodynamics. Then we have a computer screen, the internet, all of these things with, fiber optics, all these, if you look in a computer, there's capacitors in the computer. That's electrodynamics. Whitson and all this saying that gravity is and all this stuff. These people understand electrodynamics because they make capacitors that are integral parts of computers and transistors and circuits, right? These people understand thermodynamics because they make power plants, right? And batteries. They understand chemistry because they make medicine, right? And lotion and all the different things that we use throughout the day. So even flat earthers, the fact that you don't have any technology of your own, you have to rely on the technology and the people you see are wrong. It shows how silly the whole discussion is. But again, I think for the most part, like to a certain extent, I was trying to help people and wake people up. I just basically got this point and just realized that this is it's just a waste of time. I mean, there are people who come out of it like journalism just did. And you could, I could count like 5 people that I know of who was publicly who did. But journalism, you had to literally bring him to Antarctica. All the evidence he's been shown, you had to literally bring him to Antarctica for tens of thousands of dollars. It's not worth it to me. Apparently, Duffy is a rich guy. He was able to do that. I'm not spending $80,000 worth of time to convince somebody that the Earth is a globe. When we're using GPS on a regular basis, that's only in existence because satellites are going around the globe Earth. I mean, it's just so when you get out of the echo chamber, and that's what I realized. The people on the globe side who are in that discussion, they get stuck too. You notice how they changed the argument, like they don't mention photos anymore because flat earthers denies photos from space, and they don't mention so many things they don't talk about to match the denial of flat earthers. And what happens is I notice their world starts to shrink. That's what I noticed was going on to me. My perspective was starting to look from that small area. So now, since I got out of that and I'm just looking at the world as a whole again, I'm just so much happier, so much freer, and 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 I'm able to look back and see how limiting of a view even just engaging in constant discussions with these flat earthers is. So there you go. Lisa says just basic navigation. Trump. Like I said, I didn't really look into Trump so much, except for I know that Trump wrote that executive order saying that the government funded organizations can no longer put men and women sports. I agree with that idea. So I don't believe in or agree with or participate in the transgender ideology at all. I will never call a man a woman or a man a she or her, whatever they say their pronouns are. I'll never call a woman a man or him, her, or whatever she says her pronouns are. So I don't deal with that. So you know, yeah, these people are getting funded by tax dollars. Uh, these and millions and millions of dollars. It seems reasonable that they don't push this erroneous ideology. So that's pretty much the only thing I've really looked into with Trump. I kind of want to get into politics a bit more, but I kind of don't as well. I guess I don't really get into politics, but I did notice that because I was looking at that discussion. And Bansoff says, what's crazy? The apparent tunnels they have scanned under from period. Interesting, but I don't know how accurate the technology is. Um, I remember vaguely looking into that. I don't remember. It's been a while. I don't remember the details of that. I know there's tunnels and yeah, I don't remember the details of that. But I know um, I used to be big into the pyramids and stuff a while back. And Catherine says, I'm not a flirt. I rarely watch their channels, but what doesn't make sense is the fact that the moon is never upside down in the southern hemisphere as claimed by the globe model YouTubers. The moon is never upside down in the southern hemisphere. Um, well, I mean, it seems to me that that should be the case. I remember when they took pictures of the sun for the final experiment, and that was a good opportunity to bring up my sun pick if I have it in the easy spot to pull. Where do I have my sun pick at? Let me see. Oh yeah, I do have it right here. So why don't I? So looking at my sun pick here, if you look at the sunspots, you can see if you look at the pictures in the from the different locations on the globe in the following experiment of the sun, you can see how the sunspots are rotated depending on where they are. So I would just say look again, Catherine, and maybe talk to somebody who's in the northern hemisphere and make sure you get a picture of what the moon looks like and compare. And you should be able to see that that is rotated, just like how the stars rotate in a different direction from that perspective. You can say staying out of politics is less stressful. I can definitely see that. Well, look at that. So maybe we want to talk about Mickelson today after all. Let me share my screen. Let's see what we're looking like. Let's look at the geometry of this thing. And let's see if the moon should be upside down. So let's say this is the sun right here. We'll say that this is the earth here. And why don't we say that this is the North Pole up here? So this is north. So that'll make this down here the south pole. And let's say that the moon is here. And let's say that this is the north side of the moon and this is the south. And actually, let me draw a north. Actually, what's the best way to do this? Why don't we, let's draw an arrow. All right, so we have an arrow pointing on the direction of the moon, similar to how the markings on the moon faces a certain direction. So if I'm standing on the northern hemisphere up here, and I'm looking at the moon, it looks to me like the arrow is pointing up. But if I'm standing on this side and I'm looking at the moon, it looks to me like the arrow is pointing down. So, like I said, I haven't seen specifically with the moon because I don't think I don't know. I don't. Duffy said that they took pictures of the 24-hour moon, but I don't think they got to releasing that data yet because they have so much data. I think they taking time to process it. But similar to the sun pic there, just like how if these were spots, like if I had two spots up here and one down here, the person in the northern hemisphere would see two spots up, and the person in the southern hemisphere would see one spot up. So the moon is my understanding, like looking at it from this perspective, the moon should look upside down to the people in the south. So I could take a look real fast and see comparison. Southern hemisphere. Right. So one of the things, so let's look at this page I found here. Share this screen. So this is moon phases as seen between the two. So according to this, which makes sense, because the moon is moving around. So we're looking at the North Pole here. So the North Pole is on the Earth is here. The moon is, in my understanding, is moving around the Earth in this direction, and the sun is still on this side over here. So the moon in the northern hemisphere will go from if it was here, we would see what? We would see a half moon with the right side from the northern hemisphere lit. Here we would see a full moon, whereas in the southern hemisphere we would see what the left side lit, and that's what they're saying, right? So if you look at this image here in the northern hemisphere, we see the right side lit. You can see my mouse there. And in the southern hemisphere, it looks like the left side is lit because you're upside down, but the sun is in the sun is the moon is still on this side, but it switches. So maybe that's what they meant, but it still seems to me like it should seem upside down. But you just have to, I guess, to get somebody who can get you some pictures from both. So no, sorry, I mentioned flat Earth now. Yeah, usually leads on. Uh, But I mean, hey, I'm the one who did the debates for a while, so I'm sure I'll keep on getting it mentioned for a while onward. And it's okay. I mean, maybe some more people are awake. Sorry, my thing, my hand must have hit the. It's very easy to mute this thing. Maybe I need to turn it around or something. Sorry about that. I was saying, instead of hearing Mikkelsen and Morley, would you all like to hear my presentation? I'll let y'all know that I went out of town a few weeks ago. That was that week that I did the recorded premiere, and I gave a presentation on my research. Sounds good? Awesome. So let me load that presentation, and maybe I'll do that today. And I've actually updated it a bit. Let me give you all the most recent one. I updated it, not much, but I put, I'm going to, where am I going to present it at? I'm going to do something with it. I gotta remember. I've been doing so much. I have two more presentations coming up. Um, one on the 9th of April, one on the 11th of April, poster presentation. So I've been getting the poster done. And I feel like I'm going to be presenting it somewhere. I put it all the stuff on my calendar. So usually I just put it on my calendar and forget about it, and I see it when it comes up on my calendar. So let's get the most recent one here. Boom. All right, so here we go. So this is my.
All
Oh,
right. So for our next presenter, we have Mr. Daryl Burry. He's with University of Texas at Austin, studying astronomy, and his research title is
and
Stellar
it's
Collisions
actually,
as a
y'all could probably
Function
hear the audio.
of Praesepe.
They probably want me to. Uh, oh, I know what I have to do. Hold up. I need to turn off the um, automatic do audio. Come on. Try this again. All right. What I'll do is just save it with no audio. So give me a moment. I'll save it as with no audio instead of trying to figure it out. And that way we won't have the audio thing going on. Boom. All right, there we go. So that was an easy fix. And let me place it on a different screen so I can still see your chats. There we go. Awesome. So this is perfect. I'll see Auckland Bandsaw. I'll see you next time. All right, so let me share my presentation. Y'all be able to see what's going on. This the one? Nope. This is the one. Okay, here we go. And let me clear all the filters. Awesome. All right, there we go. So now y'all can see that. And that's my LinkedIn, by the way. The video, the link that's showing right there is my LinkedIn if anybody wanted to get it. And oh, boom. And I'll do that. Awesome. So here we go. And make it a little bit I'll actually pull up the screen here, so I can still see y'all's chats. Boom. Awesome. I have everything set. I can see y'all's chats, even though you might not be able to see it on the screen. So if you have any questions, let me know, and we'll get this thing going. All right. So here's my research, my presentation. So basically, the title of this presentation is the title of my paper. The scientific paper I'm writing that is going to be printed in the McNair Journal, but we're also going to try to see if we can get it printed elsewhere. And the stellar properties as a function of position in the Praesepe open cluster. And basically, what I'll do is just go ahead and go through my presentation, what I discussed, and y'all can let me know what y'all think. So this is a 26th annual University of Maryland. That's what UMD is, National Conference, McNair Scholars Conference. And so the idea was for me to uh, basically look into the stars of Praesepe, what is an open cluster. An open cluster is a cluster of stars that are loosely bound. This is what Praesepe looks like. So there's a loose cluster of stars. There's about 1,030 stars. An open cluster means that it's gravitationally bound, but there's enough distance between each stars to get a good reading on the properties of individual stars. And so it ends up working out pretty well as far as getting rotational data. Currently, there are some binary stars in the system, but most of them are single stars. And so this is a picture of what it looks like. This basically is about 670 mega years old. Uh, like I said, about 1,030 stars. The type of stars that it has are small stars like M stars, K stars. And we could talk about stellar types as well if y'all want more details about that. And so the first thing I did was I started to focus on rotation. So I spoke a bit about where rotation comes from. So you all are familiar with that picture on the left. That's a picture that I took of the sun. And the purpose of that picture is to show that if you look at the sun, there's spots on the sun. And these spots that we call sunspots or star spots, that's one of the ways that we're able to get the rotation of the sun, but recognizing that as the sun spins, it carries the spots with them. So these spots are areas of the sun where magnetic field lines arc in and out of the sun. And where these magnetic field lines arc in and out of the sun, it causes a relatively cooler part of the sun to be there, a relatively cooler area on the sun's surface. And then it looks like spots to us because they're relatively cool, so they're not as bright relatively. If you look at the picture on the right, that's a picture from the Solar Dynamics Observatory. And that shows how, if you look at the image on the left, you can see how where the spots are, it correlates with increased magnetic activity on the right. So wherever there's a spot, the reason why the spots are there is because of magnetic activity. And basically what we do is we look at those spots, and even though stars are far away, we can't see the spots individually. What we can do is we can look at these light curves of the star and simply measure the brightness of the star. So basically, when a star is, let's say, on the left side of the sun, is only blocking a little bit of the light. When it's in the center, is blocking more of the light. When it's on the side, is blocking less. When there's more spots, like if a big clump of spot comes at one time, it dims the star a lot. And what happens is the dimness of the star goes from very bright to dim to dim to most dim to bright to bright to bright. And we can look at that period of going up and down in brightness, and that's what gives us the periodicity of the star. So looking at this plot here on the left is actually a reading of one of the stars in Praesepe. So over 74 days, they looked at this star and measured how the brightness went up and down, which again will be from the stars the star spots going around the star. So when the star spot is on the side, the star is bright. When the star spot is in the middle, there's a dip, it's dimmer. When the star spot is on the other side, it's bright again. as the star spots go around, and depending on the size of the star, depending on the magnetic activity, star spots can last just a few days, or they can last several times around the star. Some of these stars only spin, it takes less than a day to spin. So there's several variables going on. But you overlap all of these readings, it outputs a peak, and then you can see the peak on the right side where it outputs the period of rotation of the star. So this star rotates at 1.59 days per rotation. And if you look at the period, you can see about every 2 days it goes up and down, looking at the time scale at the bottom and the normalized flux on the top. And the question is in the chat, Catherine says, do they have a set cycle each? Yes, they do. So what they found is, and that leads me directly into the next slide actually. One of the first things I did was I recreated plots in uh, the paper, the authors that I got the data from. So I mean, we have access to the Kepler data, and I can get the Kepler data. I did look at it directly, but I don't know how to render the data myself. So I got some of the data that was already rendered by these experts, and I redid some of their plots to confirm that I had the right data. What they were doing was showing just what you're asking, Catherine. They took the K2 satellite and they pointed it at these Praesepe stars 3 times over the course of 3 years. So that will be campaign 5, campaign 16, and campaign 18. And what they found was over a period of 3 years, the rotation of the stars remained consistent. So they confirmed that the rotation of stars is consistent at least over the period of years. So it is definitely true. So what they did was they confirmed that if we get a reading of a star and we get its period of rotation, we could be confident in that period of rotation for the foreseeable future. Now, it does change a bit because there's a lot of processes going on with a star. Like we know there's solar winds, for instance. Like, when there's a lot of solar activity, we have to be on the lookout because it'll affect our satellites. Therefore, it'll affect communications. And when the sun throws out that matter, it's throwing out some of its momentum, right? Similar to if a ice skater is spinning with arms out, we know that if they bring their arms in, they slow down. I mean, they speed up. They put their arms out, they slow down. Well, sending out that energy is almost like throwing it out really far. So the suns do slow down over long periods of time. And there's this man named Skumanich, and he found that that period of slowing down is very consistent, but is over a long period of time, to the proportional to the fact that the age of a star, if you take the square root of the age of a star, you output the proportionality of the rotation. So once you get the rotation of a star, you could even divide. There's a very consistent correlation between the age of a star and its period of rotation, because it'll slow down at a very consistent rate as it throws off matter. But over the course of a few years, it's pretty consistent. But over the course of like tens of thousands of years, you will start to see a decline. So now what I did next was, after I confirmed that I had the right data, I started just making plots of Praesepe. So this plot right here is actually a plot that I did of just plotting the stars. The cluster, as you can see, this is about the center of the cluster. It's about 110 parsecs away. Now, what a parsec is, if we look at a star and we get the parallax of a star, if the parallax angle is 1 arcsecond, then that star is 1 parsec away. That's what a parsec means. So 1 parsec means a star is far enough away that the angle it makes with the entire orbit of the Earth around the sun is 1 arcsecond. So this star constellation this star cluster is centered about 110 parsecs away. It goes as far as about 50. It's near to us about 50 parsecs, up to about 140, 150 parsecs away. And there's several different types of plots: 3D plots, plots X, Y, Z, plots the data is given to us in right ascension and declination, the different type of plots just to get an idea of what the cluster looks like. So it's actually a sort of oval-like cluster, but a sort of flattened oval. So imagine an oval that's sort of flattened a little bit like a pancake, not totally flat, but with a bulge. So that's what it's sort of shaped like, and it has about 1,030 stars. You notice I have 0, 0 mass because there is a star listed with 0 mass. And that star just doesn't seem to have any data with it. So I ended up extracting that star out in my later analysis. Some of the data, so extracting those stars. So out of the 1,030 stars, when I started to do these analysis, this analysis, if I remember right, I kept all 1,030 for this. So in this analysis, what I did was I kept all 1,030 stars and I sliced Praesepe into slices along the X, Y, and Z axis so I can overlay those slices and see in which overlay is there the fastest amount of rotation, the fastest stars, the most mass, to see if I can see some kind of pattern. So if you look at this here, basically this is a slice in the Y axis overlaid with a slice in the Z axis. And when I take the coordinates for the highest average mass, you can see that it's these 2 or 3 stars that are very big. It's just that there's big stars here too, but there's small stars near it, so it balances out. But as far as the lowest average mass, this would have been an 8 by 8 by 8 slice. So basically, I sliced Praesepe into 8 slices on the X, 8 slices on the Y, 8 slices on the Z, and also the lowest average period of rotation. Now the difficulty that I had with uh, uh, the slices was my original coding. It was imprecise coding. Like I was losing the number of stars. Like if I sliced Persepi into, let's say, 15 slices, I ended up with only 1,010 stars. If I sliced it into 20 slices, I ended up only 900 stars. So I had to improve my coding. So my research mentor advised me to, do some more research on coding, learn more about libraries. Over the winter break, I did that, and I improved my coding to that. When I did my slices again, I was able to retain all the data, but it was still difficult to overlay these slices. It was just it didn't seem amenable to the slice thing. So what I did was I improved my coding a bit more, and then I started slicing Persepi into cubes. So first I sliced this into 8 by 8 by 8, and I found a distribution similar to the previous slide. When I sliced Persepi into 50 cubes, what I found is that the fastest rotating stars, you see it is not randomly distributed. It forms sort of a ring around the center of the cluster. So the 42 fastest rotating stars, none of them are in the center of the cluster, even though a few of them curl out to the edge, but most of them are in this ring. So I thought that was pretty interesting, that the fastest rotating stars are distributed this way. What I did next was I started to do radial slices of Persepi, so I can actually have an analysis of radial shows outward from the center of mass. And looking at the radial data, I found something else interesting. So if you look at the top, this is the data on the 9th radial shell, and I started by cutting Persepi into thousands of slices, but it was like looking at individual stars. It was difficult to find any kind of pattern. And eventually what I did was I decided to do 50 slices because I had the 50 cube data. And what I found was there's a pattern where there's a sort of linear decrease in period of rotation up to about 17 plus or minus 1 parsecs. Then it reaches a minimum of 5.65 days per rotation. So it seems like, similar to the previous plot, that there is a period or a position where there's a low average period of rotation in Persepi, which is suggesting a sort of pattern in the way things are distributed, at least as far as rotation. My mentor suggested that maybe something might be the case with the spectral type. So this is a plot of the period of rotation versus spectral type. And as you can see at the 5.65 days per rotation range, there's a big absence of stars in the zero point 0.8 solar mass range. And Praesepe, it has small stars is on a small range, so we have F, G, K, and M stars there, and that's what we're looking at. So what I plan on doing in the future is looking more into the spectral type, seeing what's going on. I plan on doing a statistical analysis to see if there's an actual, statistical significance to that linear decrease that we saw here. Does it really mean anything? Is it significant statistically? Also, I want to consolidate the cube and radial analysis. I tried to do it after the fact, but it was pretty difficult. So I'm going to redo all my code and put it all in one coding to see how those two analyses correlate. See if I can find some kind of medium between the two where that minimum is. And another thing I'm going to do when I do all of that for Praesepe, I'm going to analyze multiple clusters and see if I can find a similar pattern. And what these understandings will do will help us model star clusters, understand how these clusters form better to model, understand what the environment is like. If there's turbulence in the area, determine, for instance, how the axes of stars align and things like that. And maybe even help us if one day in the future we actually go into those areas to understand what it's like in those areas. Is it very turbulent? Is it not? And so on and so forth. So it's pretty much what my presentation was. Y'all can let me know if y'all have any questions about anything. And I'll see if there's any questions in the chat. I plan on doing, by the way, is continuing with this analysis. Um, I think I'm going to see if I can do this in graduate school, but may or may not. Because they may already have something that they're working on as far as stars. I know who's likely going to be my advisor. He works on stars or dark matter, dark energy, and I find both of those interesting. So I'll see what it ends up being. But it'd be nice if I could continue with this and redo, like I was saying, the statistical analysis, um, consolidate the cubed and the spherical slices, as well as compare multiple clusters for a multi-cluster analysis. And perhaps I can discover some pattern that's going on with star clusters that might, revolutionize the game as far as modeling them. Thanks, Catherine. I appreciate it. I'm glad you appreciated it. I'm glad it's enjoyable and entertaining. I find it fun. So I like stars. I think they're amazing objects. Uh, so I love my picture of the sun there. So I'm glad I was able to incorporate it into my research. Initially, I was just calculating the rotation of the sun for my research, but my mentor was like, that's too easy. Let's do something else." So I expanded it to clusters and looking into clusters, but I wanted to do my best to try to incorporate that photo somehow. So I was able to look at rotation, and thankfully, the paper that I found and the data I found utilized sunspots to get the rotation. So I was able to incorporate that picture, so it worked out. Yes, the mathematician, I do think aliens exist. The universe is so large. The universe is so old. Like for instance, this star constellation, if I was to go back to Praesepe, these stars, it's, and I haven't done the conversion to parsecs. I don't know what the parsecs is, but light years. But when we look at that star, we're looking at it as it was when the light left it. So if I look, let's say, now we can look at galaxies that are 12, 13 billion light years away. So that means we're looking at that galaxy as it was 13 billion light years in the past, right? So if this galaxy can spawn life here, I don't see why other galaxies couldn't spawn life. Because even though we're looking at, a galaxy that's, let's say 1,000 light years away, we're seeing it as it was 1,000, or let's say even 100,000, because humanity's been around for 100,000 years, I think, 200,000. If we look at a galaxy 200,000 light years away, we're seeing that galaxy as it was 200,000 years ago. But right now in that galaxy could be a civilization like ours, even older than us, right? So yeah, I think the aliens do exist. Um, Now I do have other experiences, so I don't have a scientific basis, and I've been into the scientific thing a lot, so I haven't been delving into it as much. But ever since I was a kid, I had out of body experiences. I got to the point that I can actually cause them. I actually wrote a book about it called Travel 4. A few things I did was do experiments, like I went out of body and met other out of body explorers that confirmed it. Uh, like I had an interaction with a person. I didn't tell him about the interaction in the physical world, but when we talked on the phone, he was able to tell me what happened. I didn't tell him anything about it. So the only way he could know what happened is if he was there and we were there in the out of body state. And in that same state, I met aliens. So in my experience, they exist, but it's not a scientific basis. So I don't really talk about it in terms of science. But I think one day we'll be able to have enough technology or enough experience to validate it. But at this point, there's not a scientific basis for OBEs. But to answer your question, I think they exist. And do I think there's evidence for it? Yes. I think there's been crashes. I think that there's pictures. I've seen UFOs. I can't confirm what they were, but I've seen things in the sky that definitely weren't like conventional airplanes. Um, there's talk of Area 51. There's talk of the Roswell incident. I researched this a lot years ago. It's been a while since I looked into it in detail, but I looked into a lot of the sightings, and it seems to me that that the government has evidence in their secret chambers. But I don't have anything I could present to you that I can say is conclusive or scientific. But I think in the future we will have it. And Lisa says, by taking slices like that, is it meant to find a relationship between individual slices? How do you choose one's area over another? Well, it was just a way for me, Lisa, to break it into small chunks and get the average of the properties in that chunk. And the fact is just for one, my coding wasn't good enough at the time to do radial slices. My initial intent was to do radial slices, but I just couldn't do it. But I could do linear slices, right? And then from there I was able to do cubes, and then from there I was able to do radial slices. It also allowed me to compare the slices, linear slices, and the radial slices, the linear slices, and the cubes. But it was just to say, like, what I did was the code, let's say, slice Praesepe into 8 slices, and it said which of these slices has the most amount of mass, let's say, in the x-axis slices, and then which one of these slices in the y-axis have the most mass. So then I got the width, the position of the point in x-axis and the position of the point in y-axis, and I overlaid them, and then we have a plot like this. So now when I overlay in this one, it was the y and the z, but the concept is the same. I got the most mass in x, the most mass in y. I found the position in each, overlaid them. Now I have a two-dimensional box, and that gives me the most mass. But the issue I said that was going on with the slices, though, not all of them overlap. Like sometimes the highest area of in the X was not, it just didn't overlay, and the box didn't have any stars in it. So the slices didn't really work out too well. You know, it gave me a indication. One orientation worked, but the other two didn't. So this is the orientation that worked. It suggested that it's possible. But with the cube, there was no need for me to overlay anything. I just literally took a cube, and it was a cube of that area. Then I was able to just get the fastest rotation in that cube, the the average mass in that cube and the total mass in that cube and whatever I needed, the types of stars in that cube and everything. And of course, the radio slices, it just, comes out from there in cubes. And that was just very direct analysis, based it from the origin, which is the center of mass. So it has worked out that way. And Catherine says, Dara, thank you so much for my wrench. Is there a link I can share in chat as a way to support you? Uh, sure. You can post the link right there in the at the top there, darrellleeberryjr.com. If you can post that every once in a while, that'd be great, Catherine. I appreciate it. It'll make it easy for people to click. And on that link, it has like all my different websites. I have a STEM site that talks about STEM. I have a Next Entity site that talks about OBE stuff and of course Miracle stuff. And I have a personal site that I guess technically talks about everything. Uh, but the STEM site is like deep on STEM, and the NDE site is deep on metaphysical stuff, and the personal site is just my site, and all the discourse is there as well. And mathematician says, do I think that that alien technology is better than ours? Yes and no. So I think that there's alien civilizations that's younger than us, and there's alien civilizations that's older than us. So the ones that's older will likely have better technology, and the ones that's younger will likely have less. So I don't think they're magical or anything. They're just beings that live in a different part of the universe. They're not magical or spiritual or super, or they're just beings that live in a different part of the universe. If they started developing after us, or they develop more slower than us, then we could be more technologically advanced. Definitely, if they're coming here, they're more technologically advanced. And yes, I did see a UFO. I saw on multiple occasions. One of them, few of them, a few blocks from my house. Matter of fact, one of them I saw somebody else. He gave an account without me prompting it. Matter of fact, this might have even been below before I saw it myself. Over Lake Pontchartrain, he saw several of them, and I saw some over Lake Pontchartrain as well when I lived in New Orleans. Also saw one when I was driving on the interstate late at night. Interstate travel, I saw this glowing light in the distance, and whatever was in it shot clean from one horizon to the other horizon. So in one, I saw something come out the cloud. It was shaped like a short cylinder, and it came out the cloud. It had portals around it, and the bottom of it was glowing, and it hovered out the cloud, and I think I blacked out or something. I had like missing time. So yeah, actually gave some interviews on that years ago. If you actually go to the link at the top and go to my personal site, I have a link of all of the interviews I did. And you can see interviews where I talk about it. Some of them are on YouTube, some of them are on like the show's website or whatever. But yeah, so it's been a while. Like I know I had a period of debating flat Earth for a while, but there's been periods of times when I did different discussions on various topics on different channels. So now she got, oh, and that was a good time, by the way, the mathematician. What question did you have? What did you want me to look into? I could take a look at that. I'll get my. You're welcome, Lisa. I'm glad you enjoyed it. And I actually have I took audio of my presentation that I actually did in Maryland, and I put the original presentation as you know, a video background for us. I think I'll upload that. I've been sharing it with some of my professors. Some of them gave me some feedback on my research, and some of them were just cool professors. So, and the professor from my thermodynamics class, because he worked with me and let me take take my exam after I got back. And let him know, hey, I made a recording of I let him know when I got back. I said, thank you for working with me. And I said my presentation was a success because they gave me it wasn't a standing ovation, but they gave me an ovation and they had some very good questions afterwards. And some people came and asked me questions afterwards. I'll upload that. I'll upload that later today. Y'all be able to see it if y'all want to see the original presentation. You can hear the questions and hear the reactions from the crowd. And he was like, "Yeah, I'd be interested in hearing that." And so I actually sent them the raw stuff, but then I was like, "Oh," and I put it into a video and then sent them that as well. Catherine, I appreciate it. Okay, I'll look for it in the email. Thanks, Lisa. Thanks for checking it out, even if you can't make it live. Um, yeah, I don't have a religious belief in God. Um, so I would venture more towards the Big Bang thing. Uh, in that respect. But you know, whether God created the Earth or the Big Bang created the Earth, I don't see how that means the stations on other planets or in other galaxies. I mean, if all you have to do is look at a deep field view of the universe, there's there's as many galaxies as stars we see in the sky, and even more than that. I mean, how can you possibly have that many galaxies? Some of them are younger than us, some of them are older than us, and there's no other civilization. It's kind of like, you know, there's multiple oceans, and maybe that's not as good an analogy because technically they're all connected. There's multiple lakes in the world, and you can find life in different lakes. You know, um, there's multiple streams. You can find life in the different streams. Why is it so odd to think that we can find life in a different solar system or a different galaxy? It just seems pretty reasonable to me. What's going on, Mikey? Good to see you. Thanks for showing up. Yeah, well, I'll point out that science is not necessarily meant to be believed, but I see what you mean, though. But science is more about looking at the evidence, seeing where it leads. That's why I need to do more experimentation on OBE, some more experiments. I mean, I did enough to convince me, but I definitely to make us write a scientific paper on it. So I plan on practicing again and doing more experiments with other explorers and see if I can confirm or do enough experiments to show that we are having communication without physical, you know, interaction. But I did enough to know from my own personal conviction that we had communication without physical interaction. And here's a problem. Let me uh, share this problem that we have here. And if you want to email me, my email is on the website linked at the top, dvj@darrellleeberry.jr.com. And I'll share the this window here. We'll take a look and see what this problem is. Subject, I think this is the one. Yep, there's the one here. So why don't I crop this a bit? Right, so now y'all can see this. Let's take a look and see if I can figure out this problem here. So it says, actually need to make it a bit bigger for myself. What up? Kate took part in the quiz last night and she was the winner. There are 5 rounds of 20 questions each. The categories for each round were as follows, right? Before the quiz began, Kay had to nominate one category in which she would score 3 points per question, and one category in which she would score 2 points per question. Otherwise, correct answers scored 1 point each. There were no penalties for incorrect answers. Kay correctly answered 11 questions, and it would take more thought than I would intend at the moment. Maybe I'll look over it and maybe come the next time. So this is clearly a brain teaser. Yeah, this seems like that Harry Potter question for the Into the Chamber, because y'all read Harry Potter when no I'm the potions. Like there was a you know it's Harry Potter, so it's a children's novel technically. So I mean it wasn't like the most legit security measure. But there was a whole bunch of potions, and like the potions were in different bottles, and like one bottle was tall, and one was short, and one was this color, and one was that color, and there was a riddle, and the riddle was like, you know, the bottle they was all lined in a row, and the riddle was like the bottle to the left of the blue one might be this, but the bottle to the right of the green one is this, and the tall one is this, and Hermione, if I remember right, solved the riddle to find which one is the actual potion to get you through the next barrier. So this seems like that to me. So I'm gonna have to look at that another time. Uh, I guess I was thinking it was more like a physics problem, which I'm sure if I took the time to work this out, but I have to think about this in a different way. And Mikey says I have a guess that there was life on Mars before the core went dormant. I agree, Mikey. I agree. I bet there was life on Mars. I bet, I, you know, I've read, I'll put it that way, the idea that life was on Mars first and then migrated to Earth. And eventually, when we start to migrate to Mars ourselves, we will find evidence of civilization there. So I wouldn't be surprised if that happened. So I do think that life was actually on Mars first and then came here. But again, these are things I don't have absolute evidence for, just like I don't have absolute evidence for life on other planets, but seems reasonable to me. The planet is desolate now. The beings there needed to escape, and well, Earth is a good place to escape, so they came here. I don't know what they did to it. Maybe it was a natural disaster. Maybe it got hit by something, a meteor or something, or asteroid, I guess it would be. Maybe their own technology destroyed it, and to some extent. When then they came here, and here we are, partly destroying this world. I do hope we find that evidence as well, Mikey. So, I believe Elon's going to get us there. And I know Blue Horizon, I think, is working on it too, but I have faith in Elon. He's showing himself to get things done. So I think Starship will work and will get us there. Lisa says the first deep field image from JWST was mind blowing, especially considering it's the size of a pinky width held at arm's length. Yes. My astronomy professor, a few of them actually, showed that picture and showed some of those pictures. Yeah, it's amazing. And now they're coming up with Colby. Colby is going to be maybe I could load Colby real fast. I already have the website thing ready. But Colby is going to make JWST look bad. It's infrared because there's redshift. Like the farther we look into the universe, the farther away things are. And I mean, the farther away they are, but the farther we look into the universe, the faster they're going away from us, I meant to say. The recession velocity of the expansion is going faster. So that shifts the light. So that's why when we look farther and farther into the universe, we have to look at lower and lower wavelengths because visible light shifts down to infrared and stuff like that. So here's the Colby site right here. And apparently this thing is so advanced that it's going to make JWST look bad. And when I was visiting one of the colleges I was considering for graduate school, one of the professors had a comparison on the wall between JWST and Colby. I believe it's Colby. No, maybe I'm thinking about the wrong satellite. This is from 1989. When it is infrared, I guess it just is it getting in position? Okay, maybe I'm thinking about the wrong satellite. Which one am I thinking about? Maybe it must not be Kobe. This is an old one. I don't remember which one it is, though. I don't remember which one. Whichever one is one that's coming out in the future. Maybe I could take a look real fast and see if I can find which one it is since I mentioned it. New infrared satellite. But suffice it to say, just like how Hubble was like this and JWST was like this, by comparison, JWST will be like this, and this new satellite will be like that. So JWST will be one small part of that big satellite, and Hubble will be like one little dot. But I don't remember the name of the satellite. I guess I should remember. I don't know why I was thinking it was Kobe. Maybe they have another Kobe. Sometimes they redo satellites and rename them. But suffice it to say, my astronomy research professor talked about it, and this professor, his researcher at one of these schools talked about it and had a poster on the wall of the comparison. So it's coming. So you're going to be blown away again. If you're blown away by JWST, you're going to be blown away again when that data starts coming out. And the mathematician says, I hope you came with an explanation and proof of aliens. I love astronomy, especially with you, sir. Awesome. Thank you. Thank you, mathematician. Oh, yeah, I would say so. It looks like but that's the first thing I thought when I saw it. I always have problems saying that word. Combinatorics. Combinatorics. I'm going to have to look at that another time. I was thinking it was a physics problem. I thought you would say that. 116 or 118. Oh, let me share it again and share it more clearly. Put up here. Two. There you go. It's that problem there. Anybody were interested in it? And if somebody works out a solution, perhaps somebody else will come with a solution next week. So there you go. You can see it in all its glory. Oh, awesome. Now the bishop says, how many hours do I study a day? A lot. It's pretty much all I do. Even though I took a break today and I play some video games, it's rare for me to take a break. I study many hours a day. Either I'm studying for class or now I'm studying to help my tuti. Is that the right word? Tuti? So either I'm studying for my classes, I'm studying to help my tuti, or I'm studying for my research. I won't really study for my research a lot until the summer, because I've finished this first leg, so now it's just presenting it in a few places what I did so far. But over the summer, I'm gonna work on what y'all saw me mentioning that in my ongoing research. Got to still make my good grades for this last semester. So actually dropped cosmology. That class was horrible. Thankfully, I was able to cover it because I'm getting 2 degrees. Thankfully, I had enough classes and enough higher level classes to fill that void. So I'll still get my 2 degrees. So I have relativity right now. I have thermodynamics. Those are the hardest two. Quantum. How could I forget quantum? Quantum. So really, I think the hardest will probably be quantum two. Quantum two is my hardest. Thermodynamics is the next hardest, and I have relativity, which is thankfully I don't have any exams in that class, so that makes it not as hard. But I have to write a paper if I'm reading about Michelson and Morley. Then I have creating scientific apparatus where I'm building an experiment that's based upon the Coulomb force. I'll do a presentation on that for y'all in the future. I'm still working on it, but I built this nice little board where I can do different Coulomb force experiments, and so when I'm studying to help my 2T. with his physics class. Oh, it says, hold up. It says, let me read the whole thing. I believe I read the first part. So it says, K correctly answers 11 questions in the first round, 15 in the second round, 18 in the third round, 15 in the fourth round, and 12 in the fifth round. Her winning total is 116 points. Which category did K nominate for 3 points per question, and which category did she nominate for 2 points per question? It might not be combinatorics. It might be something different. I suppose it could be solved like that. But it's definitely a different way of thinking than I'm used to. So, definitely a different way of thinking than I'm used to. But awesome. Let me know if y'all have any more questions. I'll close up momentarily. Always good seeing y'all. Let me know what topic y'all would like next week. If there's not much interest for the Michelson model, y'all can let me know what y'all want to discuss. Maybe I could discuss some quantum. Maybe I could discuss some or different type of relativity. Maybe some thermo. I know people like thermo. Right now, we're getting heavier have we gotten past the second law? We passed the third law. Now we're doing enthalpy and Gibbs free energy and free energy. So that's what we're working on now in thermodynamics. So I'll make a post. Y'all can let me know what y'all like to see. And WC, remind me what that is. I'm sorry. Your WC. Oh, welcome. Awesome. Well, thank y'all. Good seeing y'all. I'll see y'all next week. I'll make a post for topics and I'll upload that. If y'all want to see the actual Maryland presentation, I'll upload that like in a few minutes if y'all want to see it. And I'll see y'all next time.